doing my quiz on the laptop here, and so I'm going to be flipping in and out. Okay. Okay, so it looks like we have to do the soccer shoes first.
Yes. Yeah. Should we start with a prayer though?
Oh yeah, well, we probably should do that. Okay. Well, I know I said it last week, so whose turn is it?
I'll say it.
Okay, all yours.
All right. Our dear Heavenly Father, we're so thankful that we can gather here as a group to go over the material we learned today. Father, please bless that we can stick to it and push through any parts that may give us difficulty, that through each other and the Holy Spirit we'll be able to learn from each other and teach each other. Please bless that as we do this, we will gain insight and it'll stick with us for the duration of this study period. And we say these things humbly in the name of Jesus Christ. Amen.
Amen. Thank you for that.
Yeah.
And I have started to consider whether or not I'm over my head here.
I usually am. I'm used to swimming in the deep.
I'm not. So, okay. So first, okay, guess we get the soccer shoes up onto the ANOVA is how he says it.
Sure.
Okay. The first question is fairly simple. In an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. That's true, right, guys?
Yep.
Right.
Yep.
All right.
That's what I put.
That's what I put.
So what requirements need to be checked when performing ANOVA hypothesis test? Mark, all that apply? I'm thinking data in each group are normally distributed as a definitive yes.
Yeah. That's
Variances are, and that they're all equal. I'm like, well, they could be some degrees apart, so that doesn't make them equal. It doesn't necessarily mean.
Yeah, that doesn't mean equal. I don't know, because it says the populations have the same variances. Check if largest standard deviation is no more than 2 times the smallest standard deviation. So
Yeah, and I talked about doing 4 times, yeah.
So they're not all.
And then the sample.
Well, but in the book it says the requirements for ANOVA, and it says the 2 requirements of the data are normally distributed in each group, and that the variances are equal for each group.
Okay, we'll go with the book.
And then also that they're independent and all simple random samples too.
That was in the book.
Right.
Okay.
I just caught that the variances there'd be that little fluctuation and that would be okay. So I thought, is that really what that's asking for? Just that the variance is constant at the end, it says. And no more than 4 times a small variance. That's where I was a little hesitant on saying that. At least.
Yeah, let's go with those. I'm going to go with those 2, and we'll see what happens.
Yeah, we'll try that.
Because it does say the data is normally distributed and the variances are equal for each group. So.
Yeah, and the 4-time rules is how you check to see if it's equal.
Yeah, exactly. Okay.
All right.
To check if each group is normally distributed, do the following. I think it's to construct the QQ plot.
Yes, that's what I said.
Yeah.
Yeah.
What I have on my screen, so I hope that's right.
Alrighty. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size. I'm thinking it's 3.
That's what I'm thinking.
I think it's 2, isn't it?
The largest variance is less than 4 times the smallest variance. I would go with that one as well.
I thought I swear I thought in the homework they in one of the lessons, yeah, didn't it say, oh no, that was your standard deviation.
Yeah.
My bad, that's what I was thinking of.
Yeah, it says the rule we will use is if the largest variance is less than or
Right.
equal to 4 times.
Okay, yeah, you guys are right. Sorry, I was thinking of like question 2 from part 1 for the prep.
Yeah, I was thinking the same thing there. So, okay. Are we back to me again here? Let's see. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? Huh. What?
About 6 is what I would say.
If there's 3 samples, there's 3 pairs.
Right.
But how many pairs when there are 4 samples?
You attempted to say 4.
Well, yeah, but that's not can't be right.
Exactly. So 6 would be it, I would guess too.
You got 1, 2, 1, 3.
See, this part I didn't really catch on to. No clue.
Let's try 6.
Yeah, I think it's 6 because there's
Oh,
1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and then 3, 4.
Yeah,
yeah,
that's why I'm saying 6.
okay. Alrighty. We'll go 6.
Because I think what it's doing is it has to compare each one. So if you take 1 and compare it to 2, 3, and 4, and then you go to 2 and compare it to 3 and 4, and then you jump to 3 and compare it to 4. That's really crazy, but and then I think there's a way to calculate that.
Yeah, there's 6. Okay. Yeah. Okay. So you're only doing it, counting it one time. You're not reversing them and counting them again. Okay.
No.
Yeah.
Okie doke. Now we got to get the soccer. Okay.
Is it my turn again?
I believe so.
All right. The data in the soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing the socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Oh, smaller numbers are more accurate. Use the scenario above to answer the next 5 questions. What is the minimum or smallest variance for the 6 groups, and round to the nearest 3 decimals? All right, so I plugged in those numbers into that handy dandy tool.
And which one are we using on this? Which Excel sheet?
Yeah,
It,
well,
It's the what?
it's the ANOVA tab.
That's what I thought, but it has so many, because we're doing multiple variables. So do we just paste it in one of them?
no.
You look at the column A in the soccer shoes, tells you
Right.
which type of footwear, and so for all of the A's would be one column, all the B's would be another column. You got to go.
Gotcha. Okay. I was wondering about that. All right.
So I've got all my numbers plugged in. What is the minimum or smallest variance? And I have the smallest variance at 27.208.
That's what I got.
Yeah, me too.
Sorry, I'm still trying to paste it all.
No worries, it takes a little bit. And then the next is the maximum while you're at it. So, which I got was 53.158.
Yep. That's what I got. While Zach's doing that, did you guys watch that last video on this lesson? The one with the guy in the chalkboard?
I
What's he doing with this Excel sheet where he keeps going up to the analyze and pull it down? Is he using the other system? Not the Excel sheets? He's getting the same stuff as I am. It was very confusing to me. I was like, okay, where's he going and why is he going up to analyze and then pulling over and, putting stuff in different groups?
Yeah, I'm not gonna lie, I didn't watch that video.
I don't know what he was doing. I think I finally decided he must be creating this ANOVA sheet that we already have available to us.
And then in variable 6, do we do the socks? Is that
Yep.
what we're, okay.
yes.
Alrighty. So then we would be on, let me double check the answers you guys all got. Okay, so the minimum variance. Is that 29.450? Or right, no, that's the mean. The minimum variance,
Top squares.
It's in that little upper section where you have the variables.
Descriptive.
okay, so I see it. It's right under statistics.
Yeah.
Okay, so then is that 27.208?
Yep.
Right.
Okay. And then, let's see, 7.208. And then number 9.
When a girl
Maximum.
finally gets that ring,
Would be 53.158.
Yeah, that's it.
Right.
Okay.
Okay, so we created a QQ plot. The test for equal variances is satisfied in these data. Is that true? I think so.
I don't see 4 times the difference, so I would say
No.
true.
Yeah.
I got my little QQ plot up there on the screen with all my pretty colors, and they all look pretty good to me.
How do you make a QQ plot again?
I went up to charts up at the top,
Right?
and I just, wrong mouse, hang on. I went up to charts at the top and that little arrow down in the corner, and then I chose the QQ. And it used all the information I already had in there. I'm sorry. I chose box and whisker is what I chose.
You
And
have
it
to
creates a little
insert.
box right there on my screen.
Okay, I see.
It kind of just pulls your data in there. It's awesome. Sometimes when it works. Well, last night I couldn't get it to work. So. And I just left it there on my ANOVA screen, down below the boxes. So when I change what I have in my variables, it changes my box
So
plot.
which one is the QQ plot under?
Oh, I didn't do a QQ plot because I couldn't find it, so I did a box and whisker.
Oh, a box and whisker one instead.
But it kind of shows you that they're all kind of right there in the same area. You could probably use one of the other ones for the QQ plot, even though I don't have one on my machine. Let's see. We could use, oh, mine's not very good. We could do a scatter, but that's, nah.
Yeah. Got the histogram, box and whisper.
You could kind of do one that says stock on it. Kind of goes up, but
Well, instead of just grabbing all of them, what if I just grab one? I thought I saw an option for that somewhere.
you know what? Oh, I wonder if it's in the analysis box. Let's see. No, histogram's there. No, sampling, z-test, regression. Div.
Descriptive statistics icon in the toolbar. Do we all have 2016?
Yeah.
Looks like it.
Not what I wanted.
So I mean,
Best to create one, but I don't know how to create one.
I mean, I kind of figure out how to create one at a time. You can just create well, first you have to sort it in numerical order, and then you can just do a scatter plot and then add a trend line. And if the plot is close to the trend line, then it should be. It basically looks like a QQ plot.
Okay, let's try that.
Do we have like an extra tab for sorting data? No. Which version?
You do. It's on home. It's sort and filter towards the far right-hand side.
Sorry, say that again?
Your sort and filter is on the far right-hand bar on your home page, on the Excel. The sort and filter.
Yeah.
You can highlight everything and sort it off from lowest to highest.
Too bad we can't use the quantitative descriptive statistics QQ plot.
Probably could.
There's only room for one variable. There's not.
You could do one at a time.
I guess that's true. You could.
And
And
if
just
each
check
one,
and see if each one's normal.
right. And if each one looks normal, then the answer is yes, they all look normal.
They're normal, yeah. So this must be what he was doing, perform an ANOVA test in the SPSS.
Probably, yeah, because they kept using that SPSS on the videos.
Yeah, but I think it's already here in the Excel sheet. I don't think we need to actually set our system up for that. I don't know about you guys. I, for one, do not want to learn a new system right now.
Yeah.
I'm having a hard enough time just grasping the concepts here.
I'm with
The
you.
business class that goes with this one is dealing with Excel.
Well, you know what's bad is I did take an Excel class.
Whoa.
And I'm stupid on it. I guess I better take it again.
That doesn't look normal at all. Holy crud.
I wonder if I did this.
Has anyone tried copying and pasting it over into the QQ plot?
No.
I was working on it, but
I've been doing it, and none of these are normal. There might be like 2 or 3 points on the line, but the rest of them are way out in the boonies.
Really?
Yeah.
Okay, well. So are we saying it's not normal then?
But wait, what are you using?
You know the quantitative descriptive statistics, how it has the QQ plots tab?
Oh
I
yeah.
have been copying like one, I've been copying one of the variables from our inference procedures, and I've been going over to the QQ plot on the other one and pasting it in there one at a time, and none of them look normal at all.
Did you sort them from smallest to largest first?
That's true. I didn't do that. I totally forgot to do that.
That'll make it look a little strange.
Yeah, because like right now it
That's
just
strange.
looks like, I'll tell you what, it looks like stars in the sky. Just
Yeah, I totally forgot that QQ plot was even there, but I went in there and I sorted them first, and they're looking pretty good to me.
okay, good.
It's the same thing.
I'm
and
glad somebody thought to do that, because I would have steered us down a dark path.
Yeah, I've done 2 of them so far, and they're both looking normal. actually.
Awesome.
Yeah, kind of just go up in a straight line there. So I would say yes on that.
Alrighty.
See,
So now we're going to remove the socks. Whose turn is it?
I don't even remember who read last, so I'll read. Perform an ANOVA test in SPSS and observe the p-value is 0.081. Then remove the stocks data and perform the test again. The SOX data and perform the test again. What is the p-value when we remove the SOX data?
Alrighty.
Get out of here, SOX. I got 0.309.
Yep.
As-
That's what I got.
Yep, me too.
all right, I gotta go clear my data. Except my bar disappeared.
Okay. The test statistic for a ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic? I have it right here somewhere.
All right, so when you cleared out,
Right.
when I cleared out my data, I have pound divisible by 0.
Lost your values. You may have to close it and go back in.
All right,
Yeah.
or maybe let me undo. And all you did was clear out the variables, right?
No, just
For
variable
the
soup.
SOX.
Oh, the socks one. I got
Yeah,
it.
everything else.
I got it. You know, this is really annoying. I gotta go get my.
All right, so the book says the p-value for the ANOVA test is the area in the right tail.
Yep.
Right.
Yeah, right tail.
All right, cool.
And it's also right on our chart.
Yep.
All right, so now we gotta go get the other data. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, which is mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, sodium level. Their data is available in the file and use it to answering the following. Examine the calories first. Construct a QQ plot of all the calories for each of the 3 types of hot dogs. Compare the variance to determine if the assumptions to use ANOVA have been met. Now let's go plug in numbers.
Doing QQ plots first, huh?
So first we're looking at calories. Do you find that you have to enable the spreadsheet to copy the data from it properly?
Yeah. Sometimes I do, sometimes I don't.
Well, shoot.
That's what I did.
So do we just have the calories and sodium tables?
Yeah.
But I think we're just comparing the calories right now, right?
Right.
Why do I have less meat than I had beef?
My scatter plots look normal. Just saying.
Okay. Do you guys have more beef than you do of the meat and poultry?
Yeah.
Yes.
3 more.
Yeah, they're looking all good to me.
20, 17, and 17. Yeah, the scatter plots look fine.
Yep. All right, cool.
So it says, let's examine calories first. Compare the variance to determine if the assumptions have been met. Our answers can be the assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots, and we can also assume that all variances are equal.
That's what I would say at this point.
I don't know that it means that we need to read anymore, because that's really, I think that's it.
Yeah, that's it.
That's what I would say.
Yeah, I agree.
All right, run ANOVA to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, which I do, and that the F is 16.074. Let me go over. Yes.
Yep.
And the P is 0.000.
Yeah. Watch the V. Okay.
Where's our level of significance shown in here?
0.05.
Yeah, that's what they said too, with the level of significance.
Yeah.
Or it's assumed it's 0.05 in the background in the formulas.
Yeah. So if you're,
I think it's the last one.
I think you're right.
Yeah.
Agreed.
All right.
Now we're going to do sodium levels.
Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the 3 types of hot dogs. You should see the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75, and the largest is 10,492.871. Have the assumptions been met to use ANOVA?
Doesn't sound like it.
Well, the QQ plots don't look good. There's one there on the meat one where it's got a sharp incline, but it does keep going up.
I mean, they all look. I mean, I think they all look pretty good. The chicken or the poultry looks a little different, but it's still pretty much along that line.
Yeah,
Yeah,
they're all going up. So.
I didn't see any things that stood out like, ooh, that's crazy.
Yeah. So we figured number 1 again.
Yeah, I would say so because they all, like you say, seem relatively,
Normal.
yeah.
Okay.
The second grouping in the meat,
Right.
Doesn't it?
when I have 144 jumping to 511 or 506 on a map, it really doesn't. It doesn't. It like you've got it where you've got one that really stands out. Like all of them look for the most like in the line, and you got two of them that jump way out. Well, mine might be not sorted right, but that one that's down in the 100.
144, and then it goes to 3.
Yeah, that one doesn't line up with the rest of them.
Right, but it's not 4 times. Greater.
I don't know. It makes me question because the next one says, despite the possible problem with the QQ plot with poultry.
The poultry.
So I'm like, well, what's the problem?
Right.
I didn't see poultry, but maybe with the meat. I saw with the meat.
I didn't see anything wrong with any of them.
Yeah, that's what I was saying.
I thought that the QQ plots, if you had it going up and then going down, or if it, you had an extreme out one way and extreme out the other way, it didn't actually, couldn't really follow the line up, then it was wrong. But these you can follow the line up. I mean, the poultry goes along the same place for a long ways before it goes up, and then it goes along the same plane again for a while. But
Yeah, just when you have that.
Yeah, it's
Yeah, 'cause
definitely
it
being
just
tricky.
that one is way off from the others. The others run between 3 to
I don't know, maybe-
550.
Maybe for that poultry one, it isn't necessarily normally distributed just because, it does look a little different than the other ones we've done.
The meat one, that 144 has me concerned.
I don't think the meat one's even in question, though, because it mentions specifically the poultry.
Yeah.
So that's one we got to look at.
All right, let's do that one again.
okay, so we're going back.
Oh, that one's got that nice V in the middle of it.
Yes, so should we, we're going back to
Well,
question,
I'm going to resort mine again.
going back to 16 again then, and say it has not been met?
Oh, hold on. I'm going to sort mine again.
Yeah, I almost think it would be 3.
Yeah. They've not been met, but it's safe to assume.
It's assumed that the variances are equal, but it's not safe to assume that the group comes from a normally distributed population.
Yeah, so if I look at 3, where I have them all sorted, I mean, it takes a little jump, but it's nothing off kilter, so I don't see anything wrong with the poultry.
Yeah.
That one doesn't concern me. The one with the meat does concern me because I have one that's 144 and it's so far off base, but everything else looks perfect. You just got one odd man out and everything else looks fine.
But, I mean, again, I think the reason the poultry is the one we got to look at is because that's what the question mentions. It doesn't really...
I
Yeah.
don't see anything with poultry.
Yeah.
But you could be right.
I think
Maybe
just
it's not because of the meat. I don't know, because, I mean, that 144 still looks kind of close to the line to me on the meat. Like, it isn't crazy off base.
Yeah.
But
I'm with you. The poultry gives me pause. That's the only one that does.
And the meat paused me for on that 144, but the poultry, it's almost like the bar just moved a little bit.
I think it's been renewed, outdated. Doesn't work.
well, it's just more like it just looks like 2 little bars versus one long continuous bar. Whereas, I mean, the 144 is quite a bit lower in the meat category than the other ones, but it still is pretty close to the line when you look at the graph. It isn't far away from the line at all. There's other plots that are further away from the line than the 144. It's just a lower number. But it's still in
yeah.
accordance with the line.
Nothing that jumps out at you like, man, we can't do that.
So yeah, anyways, I think it's 3. I think
Yeah.
that's safe to assume just with the next question. And if we're wrong, then we'll try again.
That's right.
So
Go ahead.
the assumptions have not been met.
Yeah, we'll go 3, I think.
But we can assume the variances are equal.
Are you guys ready for the next one?
Yep.
Yep.
Despite the possible problems with
Point one.
What?
Go ahead.
Despite the possible problem with the QQ plot for poultry, you decided to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test?
I have 0.179.
Yep, me too.
Yep. Me too.
Yep. Okay. What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use the significance of alpha 0.05. I think it's the last one. We have sufficient evidence to claim that at least one of the hot dog types has a different mean sodium level.
Wait, isn't it that we don't have sufficient evidence that the p-value is higher than the level of significance?
It is.
Yeah.
If the P is low,
Yeah, then we reject them all. So,
I always get that so confused in my head.
yeah.
So yeah, I think it's that we don't have sufficient evidence to reject the claim that all 3 hot dogs have the same mean sodium levels.
Yeah, we have to have the not in there because we rejected it, right? Yeah.
Right.
If P is low, we reject the nulls. If we fail to reject it, we do not have it. I get so confused on that. I will miss that every time.
All right, 1, 2, 3, or 4.
2.
All right, we do not have sufficient evidence to reject the claim that all 3 hot dogs have the same mean sodium level.
Because P is not
And
low,
that-
so we...
That's the right answer.
Therefore,
We do not have sufficient. Do not have sufficient.
so when do we say we have sufficient evidence?
When the p-value is lower than the level of significance.
We do, then we.
I know.
Oh, then we say we do have sufficient evidence when it's.
Right.
That's what we did in
Backwards.
15.
Yeah, I keep flipping them in my head.
Yeah, I got those wrong like every time. So anyway, that's 100.
Yep. Woohoo!
So do we have another week that we can meet to go over our final project? We're supposed to discuss it.
Yeah, we need to go over our group project soon.
Yeah, well, they were supposed to discuss it in tonight's group, but we took a long time tonight. So I don't know. I'm going to go over and let me pull this back up.
We have to come up with some ideas too, so we can always throw emails back and forth.
Well, she has my email. Let's see if I can find it.
Plus, she wanted to meet with each group.
There we go.
Thursday.
You sent it today at 7 tonight. She says it's creating a Google Doc where everyone in the group can contribute. starting now, meetings and to discuss a possible research question. Ideas for questions. And she's got a whole bunch of them here that I still have a research question. Nope, wrong one. Hang on. Comparing gas prices in different parts of the country, comparing the proportion of conference talks about a particular subject from 1970 to 2010, comparing the price of items in stores, Amazon versus Walmart, Walmart versus Safeways, etc. Compare prices of homes with specific parameters, square footage, size, and lots among each of the 4 cities that the group members reside in. That might be fun. Well, let's see. I'm in Arizona. You're in Nevada. Aaron, you're where? Where are you at?
Sorry, I am having you're going in and out for me.
Oh, okay. I said, where do you live?
In Ryrie.
He lives in Idaho. I live in Idaho too.
Okay. Well, if we look at the email that she sent out, maybe we can meet later. Like I don't know, Wednesday, Friday, something.
Wednesday I can't make. But
Your meet is on
the week, I can.
Should we do our just our Thursday normal?
What's that?
Should we just do our normal Thursday?
Yeah, Thursday.
And this is to discuss our final project because it's.
Yeah, we'll have to
We
discuss
just
our
need to have it done by the 11th.
Yeah, we'll have to discuss our proposal.
We should be talking about the exam, getting ready for the exam, right?
Yeah, I know. Still in like caving in.
We'll probably have an exam review, and then we could talk about kind of what we want to do, and then try to get it all pulled together by either next Monday or next Thursday. Because then we need to ask her to join our group so she can hear it.
Yeah. Hey, if we all have an email and
You keep breaking up.
there, you're breaking up.
Yeah, you keep breaking up.
Hang on.
I hear what you're saying though about like back and forth conversations in email concerning possible ideas.
Yeah, really, I mean, really, we just need to get an idea of what we want to do, and I think everything else will come pretty smoothly after that. I think just picking this topic is going to be one of the hardest parts.
Yeah.
And I think you already had a topic you liked, Sherry. Hello? Hello?
I don't know if I can hear you.
I'm not sure.
Okay.
Can you hear us?
I can hear you. Can you hear my email?
Yeah. It sounds good.
That's supposed to be can. Ow. Okay, guys. Sorry.
Sounds good. Let's do it.
It's been a very long day.
Yeah.
My day starts at 4:30. I'm kind of fried at this time. So, okay. Thursday then.
And you get to sleep in Sunday.
Yeah.
Take an extra hour.
That's right.
I was wondering when that was happening.
Then we'll all be together.
Hey, so real quick though, for this Thursday, 6:30.
What was that?
For this Thursday, can we meet at 7:30 instead of 6:30?
I'm
I'm
fine
fine
with
too.
that.
I'm fine with that.
Okay, my work's starting to go later and later, and last week I barely made it home in time for it. So,
Okay, so 7:30 your time.
yep, 7:30, so 6:30 for you Arizonans,
And Nevada's.
Nevada.
Nevadians.
Nevadians and Arizonans. Okay, got it. See you then.
All right,
right.
sweet. Thanks.
Thank you guys.
See ya.
Bye.
We'll see ya.
Bye.